It is now 2:02 exactly on the dot, and we have the room now filled up, and we are very excited today for this webinar, Ready for the Renaissance. Imagery Content Programs deliver great data at low cost and low burden to you. So again, everybody, thank you so much for joining us. You are joined here today by our wonderful coworkers and staff here at AppGeo. We have Bill Johnson. He is our Carpe Geo evangelist. And we have David Breeding, the Director of Analytics here at AppGeo. And we're joined today by a very special guest as well. It's Jarlath O'Neill Dunn. He's the Director of the University of Vermont's Spatial Analysis Lab, so UVM, all the way up there in Burlington, Vermont. Next slide, please. Just a few things before we jump into this webinar, a few items of housekeeping. GoToWebinar, the questions box is quite small, so we just encourage everybody to pop out that questions box that you see on your GoToWebinar application. Throughout the course of this webinar, we will be making a few calls for questions, but if anything pops into your mind as you're watching this webinar, please do open up that questions box and feel free to ask as many questions as you'd like. Next slide, please. So at Applied Geographics, who are we? For those of you who may not be familiar, at Applied Geographics, we're a GIS firm founded in 1991, actually. So we've been in business for over 28 years, and we are based in Boston. We do all things geospatial, so data projects, application development, geoanalytics, technical assessments to fit in GIS to broader IT. We do strategic and business plans and the return on investment. We do studies for ROI as well. So for our technical work, we use a wide range of tools, both commercial and open source. We're big fans of open source technology. We have several business partnerships relevant to this. We include Google and Hexagon. Hexagon, of course, is one of the companies in the imagery content business, and Google was previously. We've been working with states for the past few years now on imagery content, as well as local government, private industry, for program evaluation and deployment. So we understand the situation very well. As a result, we have developed Giza, so our flagship Giza imagery streaming appliance, which is right now used by 7 states, but has very broad applications as well. So next slide, please. The agenda today, just before we go over the agenda, I just want to thank everybody once again for joining us. You can see that this is a very wide-reaching webinar. We have much of the United States represented in our audience, and we do have a map of today's attendees. So if you want to check out that map as we're going through. The imagery agenda, the agenda for the webinar, the imagery industry is changing. Why content programs are replacing custom collections for many users. So that will be Bill Johnson's portion of this presentation. Next, we will have David Breeding explaining streaming your imagery data efficiently to users from the cloud. And then next, finishing up will be Jarlath with new machine learning methods to enable you to do high value work with imagery. So once again, we really do encourage throughout the course of this webinar to ask as many questions as possible. We will not get to the questions until the end, but we will answer every question asked. So again, just pop open that questions box and ask as many questions as you can. So next slide, I want to introduce from AppGeo. This is Bill Johnson. Again, he is our Carpe Geo evangelist. And Bill, are you there?
Yes, and thank you, Jordan, for that introduction. Welcome, everybody. Next slide, please. So I want to cover a little bit about what's going on with the industry here and why you should care about these content programs. You'll notice we use the term Renaissance in the title of this presentation, and that's not by mistake. Renaissance, as you may recall, is a French word meaning rebirth, generally referring to the cultural and societal rebirth after the long period of Middle Ages into the modern era, particularly the rebirth in the arts. And we see something similar going on in the imagery business these days, and that's what we want to talk to you about today. So believe it or not, aerial imagery has been with us now for a century, 100 years or more. Wasn't long after the Wright brothers ushered in the era of flight in 1903 that somebody took a camera aboard an aircraft. And the first real widespread use of aerial imagery was actually during World War I. And since then, there's been a steady evolution of improvements in both in aircraft and in cameras and photogrammetric methods. The conversion from analog to digital to bring us up to the modern era. And once we got into the digital age, so in the 1990s, after imagery went from analog collected on film to these digital sensors that we see nowadays, GIS started to adopt orthoimagery. And I first started working with orthoimagery in the 1990s. I think many of us that are a little more senior in the profession started at about that same time as well. And now it's a ubiquitous part of almost every GIS project. In fact, it's hard to imagine a GIS project that doesn't use an imagery layer. Now, historically, it's been costly to produce this imagery, and that has meant that the government sector has been the primary source of funding it. On the national scale, originally the U.S. Geological Survey and later the U.S. Department of Agriculture have had nationwide imagery programs, plus the Homeland Security Agency, Department of Homeland Security had an urban area program called their 133 Cities program. But really, for high resolution imagery, that's been left primarily to states, state and local governments pooling their funds together to contract for high-res imagery, which I'm generally referring to as imagery at 1 foot resolution or better. And that's been the case until fairly recently. And what's actually happened in the last decade has been very interesting. We have these large internet companies that have disrupted the imagery market. Next, please. So let me explain what's going on there. So before the big internet companies got involved, if you were looking at aerial imagery, you probably either viewed it on a government website through a map viewer of some sort, such as you might see on a state GIS clearinghouse site, or you were downloading data from one of these sites and importing it into your project that way. Now, starting about 15 years ago, the internet companies started adding maps, and it quickly discovered that mapping was a very, very popular site, and also opened up a wealth of additional capabilities that improved a lot of other online applications. And this actually kicked off what I'm calling an arms race among the big internet companies to outdo each other and build better and better mapping capabilities. And so they've made huge investments in building these very comprehensive and impressive digital maps that have really democratized GIS to the masses. And that's included aerial imagery. And very interestingly, none of the users have to pay for this up front with a paywall. It's all now, it's free for use. And the way you're paying for it is the fact that you're visiting these sites and leaving your digital footprints is very valuable to the companies to drive their advertising revenues. So that's the value transfer there. So these huge investments primarily by the internet companies has really changed the market dynamic, as I'll explain in just a moment. But I want to point out that it isn't just the big internet companies. We're also seeing things like a consortium of property insurance companies across the United States have formed a consortium to acquire high resolution imagery. And we also see governments across the globe having more and more applications for imagery, both for defense and civilian purposes. Next, please. So what is this new market dynamic? Well, first of all, I want to point out that the traditional photometric companies that we've seen that have evolved over the years, they're all still there. They're doing very, very well. The main thing that's happening in the traditional photogrammetric companies is consolidations. They need to have economies of scale to be more competitive. But by and large, the traditional photogrammetric industry is alive and well. But the surge in demand has brought in new market players. So we now have new satellite companies. Many of you have heard of Planet, that has launched a large constellation of small, inexpensive satellites, and they're actually imaging the entire Earth every day. And there's a Chinese company that is in the same market space, very similar to Planet. We're also seeing as our society becomes more and more urban, and we're seeing a lot of growth in the urban areas, that this is driving a number of imagery companies that are focusing particularly on that urban area market with a combination of imagery products, both vertical and oblique. And we see, for example, Nearmap is a company that has a program where they fly every urban area multiple times per year so you can carefully monitor growth. And we see Eagle View, formerly known as Pictometry, has become kind of the dominant player in the oblique imagery market, but there's more and more companies also entering the oblique imagery market. And then for all types of imagery, we're seeing increases in resolution as they all seek to outdo each other. And it's now very common to see imagery at 6-inch resolution. The Hexagon, the company that we represent, announced in September that their program is next year going to switch over to 15 centimeter, which is 6-inch resolution, as the base product nationwide, with a higher resolution product in urban areas, where formerly it was a 1-foot product nationwide with a 6-inch in urban areas. So they're basically doubling their resolution, and we expect to see other companies doing similar things. Now, the way this works in the market is a lot of these companies have major buyers, what I'm calling a first instance buyer for the data, and that is enabling them to resell the data to additional buyers. And because they have multiple buyers for the same product, they're able to price it well below the initial cost of collection. And that's really, really important. Next, please. Next slide, please. Yeah, there we go. Thank you. So before I explain how the content programs work, let me just back up momentarily here to talk about the traditional way of contracting for imagery is what a lawyer would call work for hire. That is, you put out a contract generally via an RFP, a request for proposals. You have your own specifications. The contractor produces that work to your specifications, delivers it to you. You own it in full. You control it. In a content program, the imagery company has a standard set of program offerings. They retain ownership of the program, of the data, and sell the data to you not as something for you to own and control, but as something that they've granted rights to you to use. And because they retain the ownership, they can resell those usage rights to many other buyers. Now, this may sound like a scary proposition, but I want to point out you're already doing similar things in other parts of your life. So let's just go over a couple of those. Virtually all commercial software is sold under a license like this. When you buy software, whether it's for the Office suite that you use, or for Quicken for managing your home finances, or Photoshop to optimize your photos or whatever, you're not actually owning a copy of the software. They're granting you a right to use the software. Car leasing, about 1/3 of all cars that leave the showroom nowadays are done under a leasing program. And in a leasing program, you never own the car. The leasing company owns the car. They are granting you a right to use it for the term of the lease, generally 2 or 3 years. And it feels like your car. You use it like your car. You may even tell your friends it's your car, but it actually isn't. It belongs to the leasing company, and you have made a bargain to have a lower monthly payment in exchange for not actually owning the car. And we also see in the GIS world that a lot of commercial GIS software now comes bundled with software, and that software is subject to the terms and conditions of your software license. So it's a similar situation. And in your home entertainment needs, whether it's for music or movies, programs like Netflix or Spotify, what these companies have done is they have amassed a collection of entertainment services for you. You don't own any of it. You simply subscribe. You pay a monthly subscription fee, and you have access rights to that library. And this is very, very similar to how a content program works. Next, please. All right, so I know we have today on the webinar, we have a combination of government and non-government attendees, but if you're one of those government attendees, I have a prediction for you. I predict that you will switch from acquiring imagery through a custom contract, what we call a custom collection. And I predict that you're going to be switching to a content program. And in my mind, it's not a question of if you're going to switch, it's a question of when you're going to switch. So why do I make that prediction? Well, first of all, we see that because the cost of these custom collections is so much lower than the cost of a content program is so much lower than a custom collection, it becomes harder and harder to justify a custom collection. What I think is going to happen is that custom collections will continue to exist, but they will exist primarily for specialty purposes. But for the majority of kind of standard vanilla, if you will, imagery needs, I think those are going to be shifting more and more to the content programs. And when you think beyond the costs, when people talk about the costs of their imagery program, they generally talk about the contract cost. So if they're doing a custom contract, they probably talk about what's the total value of that contract. But if you're doing a custom collection, you have a bunch of in-house costs as well. First of all, you have to manage that contract. You have to go through the RFP process and award the contract, and then monitor that contract and make payments against that contract and accept deliveries for the products that you have to review for acceptance. And then that data, as it comes to you, you have to store it. You have to tile it for efficient delivery. You have to make download bundles that are available to your users. You load it into your imagery database, you catalog it, you create metadata. All of these things take up staff time that is a cost to you, even if you're not counting it as a cost. I think of it kind of as a hidden cost. And the flip side of that is what I'm calling opportunity costs. So if those staff that are doing all these back-end steps on your imagery program didn't have to do that because the imagery comes already ready to serve in a content program, you can redeploy them on other high-value work. Those are those opportunity costs. And that allows you to contemplate how you can make best use of those resources for other priorities rather than doing the back-end work on your imagery program. Next, please. So this switch is already underway. I'm talking about it as if it's brand new. It's actually been going on for a few years now. We have been working with a number of states. We're aware of at least 10 states that have already made the switch from where they used to do custom statewide imagery contracts and are now switched to content programs. And I see nothing but an expectation that this trend is going to continue and actually accelerate. And so there's a couple of factors behind that. First of all, these companies in the content business, imagery content business, are competing very aggressively. They all want to grow their market share. They want to become dominant in the market. And that competition is really good for you as a buyer because it really makes it a buyer's market. The competition drives pricing down, but it also drives other improvements like the licensing terms. The companies are willing to be flexible in the licensing terms to a certain extent to win you over and win your business. And they also compete to outdo each other for data quality, to have a differentiator to distinguish their firm's imagery from other firms. As I mentioned earlier, there's a race to higher and higher resolution, but not just resolution, but also timeliness. So the competition around the refresh cycles, how fast are they going to come back and produce new imagery over your area? So all of these are really good things coming out of this competition. And so you put all of this together, and I think it really results in a shrinking rationale for doing custom collections. And we're going to get to a tipping point where it's not going to be viable to continue to do custom imagery collection, and everyone will really need to do content programs unless they have some specialty needs that would require a custom contract. All right, next slide, please. So this is, this is not a scary thing. I say don't fear the reaper here. This, like we say, the custom collections aren't going to go away entirely, but I think they're going to be replaced further and further with content programs. And we think this is a win for most of you. And you're really in the buyer's seat right now with what's out there in the marketplace. You're going to spend less money. You're going to free up people on your team. Very often we're seeing that what's available in a content program is even better than what people were previously doing under their custom collection contracts. It's probably at least as good resolution and maybe higher than what you were able to afford under a custom contract. The refresh rates may be better, and even the delivery mechanisms may be better than what you've been able to support with your on-premises infrastructure. So there's a lot of good reasons to consider a content program. Next, please. I do want to point out that we get questions about two things primarily related to content programs that I want to dive a little bit deeper on. And one of those is public domain access, and the other is leaf off versus leaf on imagery. So let's just take these apart briefly. On the public domain issue, what happened in the old model where you were doing a custom collection, if you owned that imagery, if you were a government agency and you owned that imagery, you were free to do with it what you want, which include releasing it openly for the public to do with it as they want. So it's freely downloadable, for example, on your clearinghouse site. You can't do that under a content program. But I want to point out a couple of things. First of all, in a content program, the public continues to have access to the imagery. The licensing under these content programs allows the government agency to have this imagery in public-facing websites and can interact with the imagery. What they can't do is download it. And so the question really is, how much is that download worth to you? And is it really a requirement that you have? And if you think about it, it may very well not be a requirement. But if you do insist that it is a requirement, we're seeing that the content providers are willing to negotiate for a version of the data that can be downloadable. Now, that version is not going to be the same version that's you're licensing under the content program, because they need to be able to retain the ownership rights to be able to resell to other buyers. If it was able to be publicly released, they would lose their market. But they are willing to give you either a slightly older version of the imagery or a slightly downsampled version of the imagery at an additional licensing charge. So that capability is there. Let's switch to the leaf on, leaf off question. Leaf off is often desired by people using imagery because you can see the ground more clearly in forested areas. But leaf off remains a challenge, and the reason it's a challenge is the collection period for leaf off is so much shorter. We're generally talking about the period of time after the snow melts in the spring, but before the leaves pop out on the trees, which I live in upstate New York, and that period of time is a maximum of 6 to 8 weeks, where with the leaf on imagery, it could be collected all summer long, from spring through the summer and into the fall. So you can, in the Northeast, you can be collecting imagery for 6 months instead of 6 weeks. So the simple fact that the collection period is so short for leaf off means that most of the imagery that you're going to see in these content programs is going to be leaf on. And because the large internet sites that people are now used to using have this leaf on imagery, we're seeing that acceptance among the user community of leaf on imagery is generally pretty high. We know that it doesn't meet 100% of the use cases out there, and so there are situations where leaf off is much more desirable. So here's my take on that in the content space. First of all, I think the long-term prospects are competition has a way of handling this by itself. There will be companies who see a market niche for leaf off imagery and will produce higher amounts of leaf off imagery so they can differentiate themselves in the market. I really believe that's going to happen over time. In the meantime, what we're seeing is the companies may be willing to acquire leaf off for your area as opposed to their standard product. And that's something that you would need to negotiate for upfront when you're talking with these content providers. And it's generally going to be at a higher price point than what they already have on the shelf. But don't rule out the fact that what's out there as leaf on, there may be an option for you to get leaf off. And I also want to point out that if you've been traditionally using leaf off, the combination of your existing leaf off with new leaf on is a really good combination. So you get the benefit of the latest view of the ground, and in the spots where you really can't see the ground clearly, you just flip back to your older imagery. There may be places where there's new structures and things on the new imagery, but that's fine. I think you can think about that combination as a great way to get the best value out of both. And finally, there questions come up periodically about derivative products, things like if you want to compile, do stereo compilation of planimetrics or so forth from the imagery. Those kinds of products, that stereo imagery and so forth, is likely to be negotiable from a content provider as well. All right, next please. So the bottom line is, you have choices now. You have more choices than ever. And these choices really put you in the driver's seat, making it a buyer's market. We really think it's a high upside for these content programs. And we think that the downsides, there are ways to deal with those, as we've just covered. And as I've mentioned previously, I really feel like it's inevitable that government buyers in particular will be switching to content. And if you accept that premise that it's an inevitable thing, then the sooner you make that switch, the more you save over the long term. If you say, well, let me just proceed with my custom collection for 1 or 2 more cycles, well, you're paying probably about 2x to do that. And so you're missing out on huge savings by delaying the switch. And, I like to talk about, what I'm calling the version 1.0 world of GIS versus the version 2.0 world. A lot of these things in the GIS world started under different circumstances, and we're in a new world now, and the imagery content is really emblematic of the kinds of things that represent the version 2.0 world. And so our invitation to you is to join the Renaissance and embrace imagery content programs. Next, please. All right, so before I turn it over to my colleague David, I just want to remind you that if you have questions, please, as the questions come to mind, pop them into that chat box, and we will be taking all the questions at the end. David?
Thanks, Bill. Always great content from Bill, and I'm going to try to blend it together with some thoughts about how you actually deliver that content if you're charged with that responsibility, or what you maybe should consider when you think about getting that content to where you need it. My name is David Breeding, and in addition to kind of ideating and developing analytics at AppGeo, I also play a big role in our product development space. And over the past few years, we developed and invested in a solution called Giza that enables the performant delivery of imagery content. What I want to talk about today, as I mentioned, is just some of those considerations and methods associated with the delivery and provisioning, and maybe ways to think about how you might improve what you're doing currently or change how you think about that process. So just to start, these assets come from 2 primary sources historically. One, Bill already noted, you can download the content, right? There's lots of places all over the web to get elements, whether they're TIFF, JPEG 2000s, kind of static images that you can deploy where you need them. But oftentimes that's a lot of data to manage, and so more often than not, you're likely getting your data from a server or a storage. There's a storage bucket which has all your information, a server somewhere that you're talking to that delivers that information, and how it delivers that, we can talk a little bit about, but it can be dynamic, which means it's waiting for requests, or it can already have all the information ready to go in tile form when we think about imagery. So focusing on that provisioning of imagery today, what people are really expecting in the space is really fast and performant delivery. I want to be able to fly through my content. I want to be able to have it like I have my Netflix, movies on hand, or like my Spotify kind of resources. I don't want to be bogged down kind of waiting for loading. That kind of, in the context of the big internet companies, as Bill talked about, the experience that people are expecting is higher, and it's a higher bar to clear when you think about your users and what they expect. The other thing to consider, imagery can come in a lot of different formats. So if you're kind of responsible or trying to cobble together resources, it can take it takes some expertise to really get that out there and get it formatted and provisioned and oriented appropriately. So something to keep in mind when you're trying to maybe build a program or create a resource to support your various use cases. The other thing to think about, if you're going to be procuring or, trying to store this yourself, or, buying a streaming kind of content program, just to know tiles are the primary way that things are being delivered, individual images, and those tiles require storage. And so one thing to be considering when you're working on the delivery of content is, as you tile more, to zoom levels, as you zoom in on Google Maps, the more you tile, the more storage you need. And so there's a balance to be had here when we think about storage. How much do I need to tile? What are the questions I'm actually trying to ask? And how, if I'm not always zooming in all the way, or if I can make my decisions at a more regional level, kind of this balance of how much to kind of tile and store versus how much can be delivered in a more dynamic way, those requests being handled and those images being returned on demand is something to consider when you think about the assets required to deliver content. Diving in a little bit more into just the behind the scenes on what's actually happening when you're kind of getting these tiles, there's this workflow here. There is, it starts with the actual raw content, that content being the imagery, what comes off the plane. And then if you want to make adjustments, there's some styling that occurs. And ultimately the chopping up of that imagery into the format necessary to deliver to your browser or deliver to your application. And at that point, once that process is done, it can either be stored in a tile cache and just ready to respond, or it can be delivered via sorry about that. It can be delivered via an imagery service endpoint. So, instead of kind of having to manage the cache or go at that, you can just go at one point of delivery. And that could be your ArcGIS server, that could be Hexagon service, that could be Giza, for example, plays that role and it blends together a variety of different imagery. The thing I didn't mention here is that dynamic tiling component. We see a modern mix of technology to really give you a performant but affordable experience will be a blend of caching techniques as well as these dynamic responses, so you can minimize the amount of storage that you really need to have to get the best performance for the best price. But so beyond the nuts and bolts of that, what else is there to consider? Is it just making sure that content shows up? What else can this process really, can you learn about this process? And we want to posit that the data, the usage data about how imagery is being used, where it's being used, by who it's being used can inform a lot of different decisions you might need to make about when you buy imagery or where you might buy imagery. So, if on the screen I have an example of a heat map, which is actually something that our Giza product can produce to show where that usage is. We work with the state of Texas, provisioning and supporting their imagery delivery. As I mentioned, heavy usership can oftentimes start new conversations. Why are you looking in that location? What's going on? If you have a larger organization, that can highlight sometimes where activities are occurring that maybe require a higher resolution kind of acquisition, or maybe shows where people are struggling. So another thing to consider. And that kind of dovetails into new user use cases, things you just didn't know about. And then also agent reporting. Oftentimes you need to prove or talk about why are we paying so much, whether, to do custom collects. Is there a better way to do that? Maybe it really makes sense. And this is that metadata can help articulate that. Or the other interesting kind of thing to think about is if you knew exactly who and where and when they were using imagery, could you more equitably kind of distribute cost among various different parts of an organization? Those heavy users could pick up their part of the tab, or you could start to make again the case on why investment is required to really support the demand that's being made of these imagery delivery mechanisms. Getting to our product here, Giza, kind of taking a play on the actual tile pyramids or the pyramids of Giza. We've built a tool that scales. We've put it in the cloud. It can deliver your imagery content at a really high rate of speed, sub-second delivery, and really allow you to kind of get your content out to your users. Because of the cloud-based infrastructure we use, the costs of storage, the costs of delivery, and the dynamic kind of that balance that I talked about, we've kind of struck that balance in an effort to, and we pass that on and allow you to kind of really get that content out there affordably. We give you that user reporting data as a part of the platform, and also can make sure that access is given to who and where spatially you want that imagery provision. So maybe you have usage kind of terms about who can see what, so you can control that. Or maybe you only want to show imagery along a pipeline and you just want to carve that out. You can do all those types of functions as a part of Giza. And finally, that cost sharing piece has been really compelling for some of our users. But if you have any more questions, please drop it in the question section. Happy to get to it at the end. And want to shift on over to my colleague, and we'll just give over the presenter controls.
And once again, If you're just joining us at 2:30, thank you for taking time out of your day to join us for this webinar. We really appreciate that. I just want to reiterate on those comments to drop any question that you might have into the questions box. Feel free to do so. And thank you so much once again for joining us.
Hi, everyone. This is Joel with O'Neill Dunce. I'm the director of the Spatial Analysis Lab. And what my team and I specialize in doing, working with organizations like AppGeo, is taking all these amazing remotely sensed data products, whether it's imagery or LiDAR out there, and turning them into information, because at some point in time, we want to use these remotely sensed data products to make decisions. Sometimes having a base map is good enough, but increasingly, we want to see features extracted from those data sets. And we're really awash with these massive amounts of data. And to give you an idea of the types of projects that we've worked on in collaboration with AppGeo in some very, very challenging landscapes. So here we are in New York City, and this is their aerial imagery. And this is the high resolution land cover data set that we've produced. So the ability to give folks wall-to-wall, very detailed data sets, 1,000 times more detailed than you get from 30-meter products such as NLCD. And doing this in different environments. That was an example from New York. Here's an example of Los Angeles, a much more arid environment. Once again, the combination here of imagery and LiDAR data and our ability to extract features with a high degree of accuracy, leveraging the latest advances in automated feature extraction and computing technology. And all this data that we have out there, one of the challenges, it's not just imagery, it's not just LiDAR, it's also our existing and our legacy vector data sets. And you've probably heard a lot about some of the new technologies about there, artificial intelligence and those types of things. And in some ways, these are revolutionizing what we can do in terms of feature extraction. In other ways, we can look at them as really just doing what we did before. And what this boils down to is that we're able to do things more quickly. The question always is, are we doing things more quickly that you can make use of? Are we achieving the accuracy that you need? And quite often when it comes to automated feature extraction, the answer is kind of somewhat, really, right? If you need high precision curb edges, that may not be something that lends itself at all to automated feature extraction. But if you're happy with slightly less accuracy, it's something that can play a role. And so, we've been here before. We've been using digital remotely sensed data technologies for decades now. We've been doing some form of automated feature extraction. And like I said, this is somewhat of a revolution, but it's a revolution that's been happening for a really long time. And we should keep in mind that, these technologies such as Landsat that first ushered this in, we're just seeing the continuation of this amazing revolution and explosion in remotely sensed data. And we should keep in mind the quotes of folks like Chuck Olson, who have urged caution, the fact that these technologies can allow us to do the feature extraction more quickly, but once again, sometimes we have to sacrifice accuracy for that. And, traditionally it's come down to these two approaches, right? On one hand, we can have manual interpretation. On the other hand, we can have automated feature extraction. I would say in most projects going forward, you're probably going to see a combination of these two, where we can leverage automated feature extraction to the full extent possible. But if we want to achieve the accuracy that we need to, or if we want to ensure the quality, we're going to need to have humans in the loop. And I also caution here, because people often think that manual interpretation is the sort of the easier one to do in a way, but when you want to extract features, especially complicated ones that have regulatory importance, things like wetlands, you really need highly trained image analysts. And so regardless of if you're doing manual interpretation or if you're generating training data for an AI system, having trained analysts in there who understand the domain and understand the problem set is absolutely crucial. It's not just about throwing CPUs or GPUs at the problem. And when it comes to any type of project, really, we encourage you to think about three things. First of all, why are you doing this? Yeah, the technology's out there, but really, why are you doing this? Once again, what are your specs? Do you need planimetric accuracy and stereo compilation, or can you sacrifice a little accuracy and save massive amounts of money? And then how are you going to update this going forward, right? Doing things once in time is generally not a long-term solution nowadays. We want to see how things change in time. We want to understand our landscapes. And quite often, it's not just using the remotely sensed data, like we talked about, but making use of all of our products out there, our legacy vector data sets in combination combination with the latest imagery and LiDAR. And so how can we leverage all of these data sets? Because in some cases, we don't need to remap everything. We just want to map the change. And so to take a look at how we can integrate these data sets, this is an example from Los Angeles here in which the background, meaning that the arid landscape, is spectrally very, very similar to the built-up environment, those impervious surfaces that they were interested in mapping here. And imagery alone didn't really provide enough information to automate that, but what we found is that bringing in LiDAR data in combination with imagery so that we could see the fact that those surfaces had been graded and flattened, and by generating this slope surface from the LiDAR data, by feeding that into the automated system, we're able to improve our accuracy by a considerable amount. And this is where the domain expertise really matters, right? If you were to just make this an imagery problem, you wouldn't succeed as much as if you used a data fusion approach. Here's another example in which we leveraged existing data sets with automated feature extraction technology in combination with AppGeo. We took the center lines for the state of New Jersey and employed an automated approach that generated road polygons. And if you look closely, these road polygons are not nearly as good as if someone digitized them. But in this case, the state was happy with the fact that this automated approach, which involved a little bit of manual quality assurance, quality control at the end, was able to save them about 1/30 of the cost as if it was a traditional manual interpretation planimetric compilation. So willing to sacrifice a little bit of accuracy in order for large amounts of savings. Another example here from a project we did in order to look at agricultural risk for waterways, and this was mapping chicken coops. And chicken coops are rather characteristic on the landscape, but they also look like warehouses and self-storage units. And when we bring these different data sets together of the imagery and the LiDAR in conjunction with the property parcel data, we're able to extract these things, and it allows us to identify these. And by looking at the context in the landscape and understanding that chicken coops are not in urbanized areas, we're able to increase our accuracy as opposed to just focusing on the geometric characteristics of that particular building. So once again, domain expertise factors into these things. It's not just about the technology itself. An interesting aspect of our project with AppGeo in mapping land cover in New York City was the fact that the city of New York had an outstanding building data set, and we wanted to take advantage of it. The problem was it was just slightly outdated, and if you've been to New York City lately, you probably know that there's a tremendous amount of construction going on there, and we wanted to ensure that the high quality of data for the building's data set was maintained, and that was done through manual feature extraction. And so we didn't want to throw automated feature extraction and remap all the buildings. What we decided to do was take a hybrid approach in which we used automated feature extraction to identify areas of likely change. So we used the imagery and the LiDAR in addition with the existing buildings data set to look at those buildings, find out those ones that had changed, meaning that maybe they were new or it appears they had been modified or perhaps removed, and then identify those, bring them back in, and then have an interpreter digitize those to maintain the standards that we had with the existing buildings data set. And this is a great example of where that hybrid approach can prevent the analysts from having to scan the entire city and focus only on those areas that have changed. And in this particular case, we're happy to overshoot our change detection a bit, because if someone goes to an area and they say, oh gosh, you know, that hasn't actually changed, that's much less of a risk than if we do miss an area that's changed. So a good example of where we can couple these technologies to speed the process in which we update our existing vector data sets. And this is an example of just what the analysts went through, where they had access to all these point locations, showing them those areas where there was either new construction or where we saw buildings had been removed, and they could go in and digitize those. So one of the big challenges we see in mapping things over time is our ever-changing standards for data, or our ever-changing specifications for data. And that could be true with imagery. We add additional spectral bands, we go to higher spatial resolution, and then in the case of LiDAR, we get more points per square meter, right? And so here's an example of a challenging project we're working on right now. centered. You're zoomed in pretty close there to a building with some trees around it. And this is the LiDAR from time period 1. And this is the LiDAR from time period 2. And this is the exact same zoom scale. And what you're noticing here is the incredible amount of detail in time period 1 compared to time period 2 as compared to time period 1. So we always want more detail. We always want better resolution. We want better data. But that does make change detection rather challenging, because if we look at a side profile of these two data sets with the LiDAR points from time period 1 in green and the LiDAR points from time period 2 in magenta, we see that in some cases the features probably haven't changed very little, or at least we don't have enough information to make the call that they've changed. In other cases, we've seen they've changed measurably. If you look on the right there, it looks like that tree's been removed. But if you look in the middle there, has that tree shrunk in some cases? Has it gained in other places? Or are we simply looking at differences in the data? And this is one of the great challenges going forward, is when we get down to this very detailed resolution, how much are we going to be able to say things have really changed? And how much are we going to be just simply confused because no matter what algorithms we throw at it, we're dealing with data with different specifications? So when we take a look at these things, keep in mind there's a lot of challenges in dealing with these data sets. They're often acquired by different vendors at different times with differing specifications. And so even if you have two LiDAR products like we have here that were on paper done with the same spec, we see that they look quite different. And so our ability to remove the differences associated with the data and try to drill in and figure out what actually changed on the landscape is really challenging. And what we end up with here is this map of tree canopy gain loss and no change for the city of New York. This is overlaid on their 2010 LiDAR. If we flip to 2017, those areas of orange of loss, you can see how they've become smooth. So a very, very valuable product, but a tremendous amount of effort went into this and understanding the source data. Once again, domain expertise and expert knowledge of the source data sets really matter when we tackle these tricky problems. So I'd like to come back to these three things that I mentioned before, right? Always stop and think, why are you doing this? What's the purpose of your project? Think about those specifications, especially your accuracy, right? Do you need to ensure that you've mapped impervious surfaces to 99.9% accuracy for each property parcel, because people are going to be taxed down to the precise centimeter of impervious surface they have? Or are you just binning your impervious surfaces into perhaps three categories, and thus you can accept some form of error for stormwater utility? And then I think this last part of how it's going to be updated going forward is very challenging. We've got these wonderful automated feature extraction technologies. The challenge is that when we unleash them on one data set and then we unleash them on the other data set, we end up with all sorts of false change out there. Sometimes that type of false change can just be those little slivers along the edge. Other times it can be much more massive due to lean in the imagery and the parallax associated with collecting imagery with different specifications. So these are things to keep in mind as we go forward. It's a bright and exciting future, but it's also filled with a lot of challenges that you folks, as consumers of this information, need to keep in mind. And back to you, Jordan.
Thank you so much, Darlith. I really appreciate that. And so we are up to our Q&A session. And so although we are at the end of the session, it doesn't mean that you can't still ask questions, so keep the questions coming. However, we will jump over to the first couple questions right now. So let's start off with this one. Are there any off-the-shelf ML or machine learning solutions that make it easy to extract features like Darlith was showing?
So, thanks, Jordan. That's an interesting question. When we think about ML, and as Darlith already laid out, it takes a little bit of background knowledge to be successful. However, there are some solutions out there in the marketplace. There are many providers like Esri and Eardas, and some more private shops that are developing ML solutions, like Attentive AI, which are trying to make ML processes and ML infrastructure more accessible. So, we would recommend that you explore and think about and go read about those solutions to see whether or not the specs align with what your use cases are. And then if not, kind of, maybe reach out and kind of consider, seeking out expert help. But I think generally speaking, these assets and kind of machine learning algorithms are going to be more accessible as time goes on. And hopefully will just make it easier for this value to be extracted from these imagery assets. But it's not there yet, but it's interesting to watch this segment of the kind of machine learning AI space kind of develop.
And do you have anything to add to that, Jarlath?
Yeah, I think I'll just add that it will be much more accessible, right? To the extent that this means that we're creating quality data, I think is still up in the air, right? And any of us know, right? We've had access to these technologies like unsupervised classification, pixel-based remote sensing technologies for ages, but it usually got you 70–80% of the way. Now some of the machine learning will get you 90% of the way, but if you need a 100% solution, you still have a lot of work to do. And we've seen situations in which you can have, on paper, a very, very successful automated feature extraction technology implementation with 95–98% accuracy. But if you're still after, that planimetric human digitized quality, sometimes the effort to go in and fix that, to get it up to that standard, can almost be as great as if you did it from scratch. And we'll need to keep that in mind going forward. And I think another one of the challenges that sometimes these technologies do require a tremendous amount of computing power. And so even though you see this implemented in ArcGIS, NV, and ArcGIS, having the computing horsepower to make use of machine learning can be out of reach, especially for a lot of municipalities, right? You don't have a dedicated GPU cluster probably sitting in the back of your town office.
Thank you, Jarlath. That was very comprehensive. David, did you have something else to?
Yeah, just to jump in on the compute power, the other kind of component of this is you do see some of the major internet providers starting to make those clusters. Those, if you wanted to provision your own GPU and you had the technology, the technical kind of wherewithal, it's becoming more accessible. However, that's another part of the growing space here. So a lot going on, and I think there's a lot more to talk about. We can talk about that in a whole other presentation. But Jordan, do we have anything else from a questions perspective?
We sure do. Thank you. And so our next question, imagery is becoming more readily accessible via cloud-based solutions, but do you see the same future with LiDAR data catching up?
That's a good question. When you think about acquisition and that effort, right? Flying to collect imagery or flying to collect LiDAR, I know at a federal level, there's still, LiDAR is oftentimes a collection asset that's being captured. Similar to the kind of history that Bill laid out, how that product kind of, is potentially, it adds more cost to a flight. I think the same logic could be applied, that it'll be more accessible, that these companies, as they seek to differentiate and add more kind of elements to their services, you could see that kind of increase in availability and potentially drop in price. The other interesting thing, as Jarlath is well aware, is the drone kind of platform, that in the sensor availability on that platform for smaller, more niche projects. I think that's another interesting angle upon which LiDAR data is entering or is becoming more available to support the various projects that require LiDAR data.
Yeah, if I can add to that, I think what is somewhat fundamentally different about LiDAR data is that you've got this point cloud, and from this point cloud, you can generate typically at least a few, and in some cases, maybe a dozen different products, right? So a point cloud can give you a digital elevation model, it can give you an intensity raster, it can give you a digital surface model, then you can subtract these, right? And so some of those products can be served up, right? Your DEMs, your hill shades, your digital surface models, just like imagery. In other cases, there's tremendous value for having that point cloud, and we've seen some very interesting technologies out there for making these point clouds available. At least what I haven't seen online yet is really a good platform that sort of allows you to ingest all of this stuff and work with it seamlessly. And a lot of us that work with LiDAR still use very specialized packages to optimize performance or the type of tools and techniques we need to do. So people are serving up the point clouds and other products online. I think the question is, how do we work with those, and if those tiled formats are, optimal for the type of hydrologic modeling or height calculations or whatever it is we need to do with them.
Thank you, Jarlath. And so keep those questions coming. We will answer every question that we get. I appreciate for asking these questions as well. So the next question we'll get to, similar to automated feature extraction, is there automated feature extraction with LiDAR? So a similar question, but yeah, we'll get into that.
Yeah, and I'm happy to take that, Jordan. There's a lot of great, just like the same AI technologies, that you're seeing with imagery, those are being applied to LiDAR. The challenge, as we see it, or one of the shortcomings of a lot of these technologies is once again, they can be really enhanced if you bring the data sets together, right? So your ability to find buildings in LiDAR, to find buildings in imagery, really gets improved if you can bring those two data sets together. And a lot of the high-end machine learning stuff now can be very, very data set specific, which I think limits its availability. And then it can't always do a good job of leveraging your existing data, such as your existing building footprints, right? Because once again, coming back to New York City, maybe you just need to update those, and those become highly tailored and customized solutions that require higher end of expertise. They're still saving you money in the end, but it's not something you're going to buy a piece of software and spin it up within a couple hours. And the other challenge that we see when we implement these technologies, especially artificial intelligence, is that it's very sensitive to your training samples. So it's not just, you click in a few places and then it's going to extract all those features. You may need thousands, you may need tens of thousands. In some cases, people are using hundreds of thousands of training samples in order to get good results. So you may have to digitize sometimes 5, 10, even up to 20% of the area to get good results. We've seen presented it in some test cases. So, do keep that in mind. It's a big money saver, but your upfront investment, both in terms of the effort to train it and the effort to implement the technology through high-end computing resources, can be substantial.
Thank you, Jarlath. So we're probably going to have another question for you, Jarlath. The next question that we have is, what are intensity images typically used for?
Yeah, so for those of you not familiar with intensity data from LiDAR, it's the strength of the signal returned to the sensor. So just like we have an image when we fly traditional passive sensors, LiDAR is an active sensor shooting out electromagnetic radiation, typically near infrared for topographic mapping. And in addition to producing point clouds, digital elevation models, digital surface models, we can produce an image based on the strength of that signal. In the past, the intensity imagery hasn't been all that useful, and that's because they haven't been able to calibrate this across the different flight lines. So you'd see an intensity image and the values would be all over the place. The vendors are getting really good at resolving that issue now. So an intensity image looks, kind of just like a funny ortho photo because it's near infrared. They can be quite useful in feature extraction for a number of reasons, because you can look at the intensity if you have ground returns at the ground, so potentially things like under the tree canopy. And they can just be useful, particularly if you've got RGB imagery. Now you've got an intensity image from your LiDAR that has near infrared. So when you fuse these data sets together, they can assist you with that feature extraction. Once again, it's bringing all those components of the LiDAR point cloud together, right? The intensity, right? The height, maybe even the number of returns. All those data sets together can really tell you a lot about the type of feature. For example, buildings and trees are both tall in LiDAR data, but trees typically generate a large number of returns due to their complicated structure, as opposed to buildings, which have hard, flat surfaces, will just generate a single return.
Thank you, Jarlath. So we do have more questions. If you have any more questions, don't hesitate to ask them. I know it is coming up to 3 o'clock right now, but we have another question. Do you need to do a QC on the automated feature extraction, say from a building footprint?
Yeah, I'm happy to tackle that again. And I would say that for all of our automated feature extraction projects that we do, the single biggest cost we have is the quality assurance, quality control, that manual editing at the end. And that's often to make single-digit performance gains in terms of our accuracy. So maybe taking a product from 95% to 98%, but it's where the majority of the budget goes. And if you're not investing the money up front, or you're not budgeting up front for the review of that algorithm and for the accuracy and quality testing of it, you really don't know how good it is, right? And once again, with all these technologies nowadays, it's really easy to produce these data sets at times using these computer clusters, but evaluating them can be a considerable effort, and you want to make sure that you budget for that. And especially if you're hiring someone to do it, you know, it's good to put that into the spec, or maybe even think about, like we do with orthophotos or LiDAR collects right now, maybe put in a spec for an independent vendor to evaluate it.
All right. So I want to thank everybody for asking questions and really having an engaging QA session. And in addition to that, I really just want to thank everybody for the really nice comments that we've gotten in the questions box. So we do appreciate you coming as well. We really appreciate the kind words. And so if you want to get in touch with any of us directly, you can see our email addresses right here, wjohnson@appgeo.com, deepreading@appgeo.com, and jarlath.o'neill/done at uvm.edu. Don't hesitate to reach out to either of those addresses or any of those addresses or myself. Everybody that's on this webinar for the most part has gotten an email invitation from me unless you signed up from social media. So do reach out if you'd like. And we wish everybody a great afternoon. Thank you so much for joining us. And I hope you join us for our next webinar.